Welcome everyone to our 16th FAIRWork webinar, today with the title AI-supported decision use cases for FAIRWork. And today our use case partners, Cyprian from FLEX and Alessandro from CRF, will introduce the updates to the use cases that we defined at the beginning of the project and give insight how far they have progressed and some insights into the evaluation. So as a short introduction, really short summary of the project. If you're interested in the project itself, you can look at our other webinars. So the main goal of FAIRWork is to create a decision support system, which we call the democratic AI-based decision support systems, which uses AI algorithms to make complex decisions by not only considering parameters from the production, from the company, but also from all the people that are involved or influenced by the decision. For example, the workers on a production line, when they are assigned through this decision support system. And we also want to support flexibility by allowing a configuration environment based on conceptual modeling. And in the middle, you can see the knowledge base and the orchestrator. So of course, we need to save the information about the persons, robots, production lines, and orchestrate all the different parts together to make them functioning. And today now we will see the use cases which we use to design and build this decision support system from our use case partners, FLEX and CRF. And therefore, I want to hand over, starting with Alessandro and CRF.
Thanks, Christian. I'm Alessandro. I work in CRF since 2006. I'm a specialist in systems for quality monitoring regarding both process and products. Next slide, please. Okay. Regarding CRF, the case study is the press shop of Mirafiori plant in Turin. They produce a total of 180 different geometries. The 95% of the production is intended to the 5 main customers with daily shipments. They are the group's press shop located in Italy, which produce Maserati, Alfa Romeo, Jeep, and Fiat, including vans. The CRF case study includes 3 scenarios. First of all, the production planning. So when produce the geometries ordered by the customers and in which quantity, with the target to produce close to the deadlines. This is the central aspect of the production. The other 2 scenarios are strictly linked to them. We have the workload balance that aims to allocate workers based on their availability, capability, and preferences in compliance with the required production. The second relates to delay of materials, where the word materials is understood in its broadest sense. It concerns all the material resources necessary to produce and deliver the components. Next slide, please. Regarding our role in the project, we are the interface between the plant and the consortium. The integration of the demonstrator in our site involves the steps described in the figure below. So the big quantity of data that the factory collects flows into the Semantics production servers. A selection of this data of interest for the project is selected and ends up in the CRF isolated project server. Then data is filtered according with our company policies and synchronized with the FAIRWork DAI-DSS knowledge base. Finally, data is processed by the remote servers of the technical partners and returned to CRF by a human machine interface to be analyzed and evaluated by the plant expert team. Just a clarification on what the output is. In the case of CRF, the output is always a suggestion about the planning. a planning that can concern production, people, or products, depending on the scenarios. Next slide, please. Okay, I will now explain the 3 case studies in more details, starting from the production planning. The goal is to meet customer orders in the quantities and deadlines requested, without occupying the warehouses for too long. It is necessary to avoid inefficiencies, therefore, on one hand, avoiding overtime, on the other hand, avoiding that the lines do not work at full capacity. The system must be able to react quickly to unforeseen events. For example, the 2 tables at the bottom right show the theoretical organization of the work shifts and the actual organization in the same period. The absence of personnel, often with short notice, makes it necessary to reschedule production. The same applies for sudden orders, line stops, or lack of other resources necessary for the production. In conclusion, regarding the KPIs adopted to evaluate the system, we need fast reaction times and multiple alternative solutions. In the long term, we assume we can improve the line of purpose, consequently be able to have a saving in the energy consumed. Next slide, please. Okay, the second scenario is the workload balance. In this case, the target is to assign workers to the different lines based on the geometry produced at the moment. The assignment is not made based exclusively on workers' suitability, that is based on his medical condition or ergonomic indexes, but also based on a multitude of other factors, for example, his experience, his preference, his resilience. The figures on the right refers to the assignment of 6 workers to an end of line for downloading of a specific molded component from the conveyor belt. Each worker has parameters associated with that specific job. The team of 6 people will therefore have a specific score. The objective is to have a fair and balanced distribution of the workforce on the lines, improving workers' well-being and maybe reducing and planning absenteeism. Next one, please. Okay, the last scenario is the delay of materials. Based on a specific request from the plant, our efforts are focused on the optimization of trucks load. An order normally consists of more than 100 containers of different shape and different stackability based on the geometry they contain. Also, the trucks that can be used have different size and capacity. The target is to fulfill all orders with the best use of trucks, maximizing the load capacity because it's not efficient to travel half-loaded. Once the order load is optimized, there may be room for improvement. Sometimes there are a couple of empty spaces, so the customer is asked if it is possible to ship in advance some containers expected for the next week. On the contrary, it may be that a couple of containers cannot be loaded. In this case, you can ask to the customer if it is possible to postpone the shipment to next week. But to start this discussion with the customer, it is useful to have a tool that quickly recalculates the arrangement of the containers until the solution is optimized. Finally, by acting in this way, we expect to improve the energy efficiency due to the orders delivery. It was the last one, I think.
Yes, thank you, Alessandro. Now we will hand over to Cyprian from FLEX, and during he shares his slides. I just want to say that we have two sites from FLEX in our project, one in Althofen, one in Timișoara. Cyprian is from Timișoara, but we'll introduce both of the use cases, all of the use cases from both sides today. So thank you very much, and I hand over to Cyprian. We'll start with FLEX Althofen.
Hello, I'm Ciprian Alexandrescu. I'm from FLEX Timișoara, but today I represent also FLEX Althofen because my colleague Roland Star is not available for this workshop. Then asked me to replace in this presentation. Okay, let's start with use cases from FLEX Althofen, which is focused mainly on machine maintenance and breakdown. This use case, for this one, they have already implemented a prototype, receive it. They make the first test. They have a promises or good results. They are working now to deploy in a production environment, and also to get more feedback from the workers, and also to have a fine tuning and make the reports, preparing the report, and so on. So, but this is in work in progress activity. In fact, what it's about in this machine and maintenance and breakdown use case, it's about to get an AI supporting tool for get faster information about how to perform the maintenance activity and fix the breakdowns of an equipment. When you talk about maintenance activity, it's also preventive maintenance and also corrective maintenance, which means in fact to fix these breakdowns. The idea behind it's like to have an assistant which is assist the employee working or which are part of this activity to get a faster solution, to get the solution how to fix a problem or how to perform a specific activity of maintenance. This will also improve the learning curve for new employee or less experienced technicians working in this area. The knowledge database behind it consists of a lot of information coming from the specification of the machines, manual of equipment, FLEX Althofen maintenance database, which is used on consists of a ticketing system where technician or people involved in maintenance activity open a ticket and record there the problem and the solution to solve that problem, the timing allocated, and so on. And also there is a part of wiki of technicians use it, which is a kind of cookbook, a kind of troubleshooting guide for the people to get faster the solution for the problem they are facing. In fact, tool it was could be implemented on any mobile device like a phone or tablet or a desktop or a laptop, which allow maintenance worker to access structured and less structured or unstructured information, but natural language, text or voice. It's like to discuss with an assistant and ask help for what is the solution in this case. Could place could be interactive in put more questions to get if the result is not very precise, could continue to put more and more questions till they got the solution, or not, because depending also the type or the knowledge database behind and so on. As a diagram or something like this, it's the operator which interaction with the tool in the normal natural language, text or voice, as I mentioned before. There is a meta model which is looking for the domain or where to look the information, and using a LLM model to look for what is the information, the right answer for that question. So once again, I mentioned this is in progress, work in progress, to validate the tool, to improve, to make the fine tuning, and in the next period, my colleague from Flex Alto will come with their feedback and trying to deploy and to use it in the production environment in normal daily activity. That is from Altophone. Going to Flex Timisoara. Here we focus on two use cases. One is verification calibration certificates, and the second one will be the work instruction transformation, for which I will mention at the end. Regarding calibration certificates, what is a calibration certificate? It's a document that certifies that specific inspection, measuring, or test equipment is functionally properly and can be used in production environment. There are various standards, industry standards and regulatory which require to have calibrated equipments in production line. Anyway, it's forbidden to use not calibrated or with some non-conformity in certification of calibration, which involve risk to produce non-conform products which cannot be catches on inspection station due to the failures in calibration reason. So, actual situation is that any certificate of calibration received from the calibration service provider need to be verified for possible unconformity as missing or even wrong information as equipment model, type, manufacturer, serial number, ID, calibration date, calibration due date, calibration results, calibration of gauges usage, issuer and approver signature, page numeration, and so on. Any unconformity found need to be analyzed and addressed if the case to the calibration service provider for clarification and correction. Then it's forbidden to let some equipment in production line which have a not clear certification of calibration. The problem is that the certification of calibration is as it is performed today, it's a manual repetitive work which is time consuming and also subject of human errors. The proposed solution is to develop an application based on AI algorithm or DAI-DSS, as it is the name used in this project, which to replace the manual verification of critical information in calibration certificate with an automatic solution. What we imagine this is the operator which is assigned to this job to feed the machine with this certification of calibration in electronic format, because we receive most of them, it's electronic format, and to get a report with all non-conformity found, if exist. Main benefits is the drastic reduction of time, use it to verify the certification of calibration, and also eliminate human error during this manual verification. There is an example of certification of calibration. There is highlighted some item that needs to be verified. It's like issue date, device type, manufacturer, model, serial number and ID, calibration date and calibration due date. You can see also even page. It's important to have the correct number of pages and page numeration to be the correct one. Once again, we get a lot of audits also on this one, and if you're incoming an auditor, need to verify if everything is conform and it's correct in this certification of calibration. Also, due dates for gauges use it for calibration results, issuer and approver signature, and so on. There is also other aspects. Where we are today and what is the next step, it's that we receive a prototype. It's a simple executable file, but seems that it's working well. We are quite happy what we have it now with the first test that we run. It's looks good. This one it's covering only one of 4 types of certification calibration that you have it. We will see later a little bit what is the image in our side with this certificate of calibration. But once again, I see there are some promises results. We have 2 people involved in this activity. It's the results are not influenced by the operator or who is using the tool. Our intention is till the end of this week to have a clear plan how to validate the tool, and then up to the end of the year, till end of December, to have a complete execution of the validation plan. Of course, will be some next step, general report, fine tuning, and so on. But it's another story. Some fine improving and so on. But at least the plan is till end of December to have a clear image about the tool. Here is the how it looks. An example for output, the result. This is one file certification. We have a failure here. There is an overview of the page. In each page is the, by the way, URS is user requirement specification. It was identified 40 cases that we need to verify for this type of certificate. And we can see for all of them in each page, it's what is the status. We have here a kind of failure. It's a minor failure. It's a kind of false cause for us because it's EBL and it's a space here, but normally it's to have in database, it's document model, it's this one. In database, you have this number, but this will be part of the fine tuning to correct such situation. Here we have also another results or another certificate where you have some 3 failures. It's in the device name, manufacturer, and model number. But after we correct in the calibration database, because it seemed it was a problem in our calibration database. All these failures, it's URS 02, 03, 04, it is pass 02, 03, 04, it was pass after it was some correction. That we already start to improve something. As I tell you before, this is the short overview or a picture of what is the situation with the certificate and calibration in FLEX Timișoara. Every year we talk about 3,100 plus certification of calibration, from which more than 3,100 are coming from 2 calibration service providers, which can be divided in 4 different category templates, which that one you can quite structured information. There is another 700 plus certificate of calibration, which is coming from different sources, which is totally big mess there. Then we cannot structure that information. For that moment, this is out of the scope for this project. So if you take a look, it's like 28. It's this one which are focusing this moment with this, that prototype that we receive it. But in case that we succeed to cover all 4 types, which is structured, which means more than 3,100, it's more than 81%, which are in scope. And if you take an average time for like 5 minutes to verify manually each certificate of calibration, this means a saving of 258 man-hour per year, about 32 working days per year for one person. Okay, this was for verification of certificate of calibration. Going to the second use case, which is station instruction card transformation or conversion to the new electronic work instruction template. For this one also we have a prototype, but let's start with what is station instruction card. It's a document containing a set of work instructions which describe clearly and precisely step by step how to perform a task within a process using test and picture for a specific workstation from the manufacturing flow. It's the it's like a Bible for the operators. What they have to do in the production line is to get conform products at the end of the line. Actual situation is like this. You have a lot of work instruction. It's more than 27K actual, we're using actual template. But once with the digitalization process in our factory, we want to migrate from the old system to an electronic one, which is using another kind of template. And this means a process to translate the information from old type to a new type of a new template. The advantages of this is to eliminate paper, to have a better revision of control, and reducing mistake by using a wrong work instruction revision, faster approval process using electronic. There's a lot of benefits. It's just to mention some. Also here we come with the proposed solution, because the translation, manual translation from old format to the new format, it involves a lot of time and huge engineering effort. The proposed solution is to develop an application which to automatically convert our work instruction from actual template to the new EVI template in order to reduce human effort, human error, and to save time. Challenge that you face is that all work instruction, or SICs, as you call it, station instruction cards, are tailored to each station in our process flow and customized for each product version. Then we face a huge diversity and complexity. A second problem, which is in fact the most painful one, is that even you have a Word document or a template for the old work instruction, the problem is the way in which it's edited. This Word document is different from every engineering to every engineering. So everyone is doing as they want. Till the end, they respect the template, but the way in which it's edit text, this edit picture, it's different and complicate our life. So here it's an example of the first page, which could be quite easy solve. It's just to take some information from this one to put in the new format. This is not a problem to take it, to identify some field from here and to place the information here. But the main problem is when you go, we focus on the exactly the work instruction where it steps. This is this is an inspection, a quality inspection work instruction, where they have to follow some information to check for specific components, to check some labels, to check some also orientation for some components, and so on, and need to translate from this format into the new format, where it involves some modification or grouping. I can enlarge a little bit. It's also a color, use it square or round around the components. There is a color code to use it to easy to identify the steps. There is a numerotation and so on, which create a lot of problem. Of course, part of them could be also found in the previews, in the old template. Others is just editing the new template. So it was done a first prototyping. In fact, it's two steps which needs to apply. It's extraction of information and picture from the old format and conversion to the new EVI. The first step, it was definitory. It's critical because if you do not extract right information, you cannot make conversion to the new EVI template. During the evaluation, it was identified a lot of challenges. Just to name of them, it's already mentioned before. It's also the problem with the Word document. It's the format of the document, which is we need the DOEX instead of doc, need to be converted. Color codes cannot be interpreted and mapped correctly. Relation of text box to UC text box cannot be identified. Also, what I mentioned here is this object or edit labels or these boxes or circles, grouping some components in the this create a lot of problem and challenging. Okay, So that's what the mechanism of like AI. It's one which interprets text and define the numbers of steps in the process non-determinism. I mean, the output can vary from each request. This means probably if I run one time, it's the order here, and the second time to be a different order or something like this. So we expect also to have a variation when you run more time. It's not to get the same output all the time. As a conclusion, it's need to, in order to have a better results, we need to pre-process the input file or the actual work instruction into better machine readable format to use it via a service. Recommendation here, it was change the format, transform multiple boxes placed over the picture to a single picture, then to have only one picture, not objects over the picture, avoiding color encoding, and focus more on text than in picture. But here you have a big contradiction, because in our work instruction, the picture is the main focus, and we want to put more picture and less text. So as a final decision, it was just to not continue with this one, because in case that we need to invest some effort in pre-processing the file, it's better to do a manual conversion, at least for this moment and in this moment. What will be in the future, we'll see, but as it is stopped for now, we decided to stop here. So that is for my side. I exceed about the timing, but I want to explain more where we are and what is the challenges. Thank you very much.
Then thank you to Cyprian, and thank you also to Alessandro. So then thank you for everyone for joining. And of course, you can keep in touch. You can contact us over the project website, or here you have the specific addresses, email addresses for the people involved in these use cases. Are there any questions? So if not, thank you very much. And then if there are no questions, then thank you everyone for joining. Hopefully we see us in our next webinar in the middle of January next year. And then have a nice day and see you soon. Bye.
Bye.
Thank you. Bye-bye. Bye.